Hi folks, today we're going to go over the 40s. You're going to need your periodic table out. 40.0 is what we're going to go over, and 40.1 is your homework. We're going to skip this part. This is something that we did in class. We're going to go right to the naming. So again, you are going to need your periodic tables out today. So on page 40, we got some different cases. Actually, we've learned how to do these already earlier on, but if you didn't or were not here for that lab or activity, then we'll go through this anyways. It says up on the top, it says case A, the first element is a metal with only one charge, and the second element is a non-metal. It tells us right here what we're going to do. It says we're going to write the name of the metal, but don't include a parentheses. And then we're going to write the non-metal with an "-ide" ending. So here we did one, magnesium on our periodic table. Move that periodic table up here. Magnesium is right here. It's only got one charge. We find oxygen, which is actually cut off our periodic table. It's over on the right-hand side. So we simply just write the name of the first element, magnesium, and we change oxygen, chop a little of the end of oxygen off, and we add "-ide." Another one's done for you over here. Potassium has only got a charge, and then we write that word potassium out, and then we change sulfur into sulfide. So let's do a couple of the other ones. RB is rubidium, and Se is selenium. So we would turn selenium into selenide. And then Ba is barium. It's only got one charge, so we simply just write barium. Barium phosphide. Again, we already did an activity with this. You all did an activity like this also back in 10th grade as well. The next case is just slightly more difficult. The first element's a metal with multiple charges, and the second element's a non-metal. What we mean by multiple charges is this part right here. What's going to be new is we're going to use Roman numerals, and those Roman numerals can be found on the back of your periodic table. So we'll go through some examples. So right here, we have our examples. You need to find iron, and iron is right here. It's element 26. And we're going to be using, I believe it's bromine. And bromine. And bromine is, again, I'll cut off our periodic table, but it would be right over in that location. So find those two elements right now. If we look at iron, we see that it does have multiple charges, and that's going to come into play as we're solving the problems. So what we do is we follow the instructions on the previous page. We write out the first element. We write iron. Since it does have multiple charges to pick from, we put a parentheses. And then we write the non-metal with an "-ide" ending. So bromine turns into bromide. And now we have to figure out the charges. So if we go find bromide in its box and at the top of its column, each bromide's got a -1 charge. But there's 3 of them, so the overall charge on bromide is 3 negative. Everything in these compounds have to add up to 0 when we're talking about ionic compounds, so it means the charge on the iron must be a 3 positive to balance it out. There's only one iron here. There's no 1 that's actually placed there, but when there's nothing there, we assume it's a 1. So this iron right here takes on that entire 3 positive charge, and that's where that comes from. I want to make sure that everyone understands when we write out these chemicals what things mean. So when I write out this one right here, I'm writing FeBr. So that's what it really looks like, but this is the shorthand version that we use in chemistry. So let's do this next one. So on this next one, Br again has a 1 negative charge. So we have a 1 negative charge and a 1 negative charge. Or if we go to the actual compound itself, each Br's got a 1 negative charge, but there's 2 of them, so that's a 2 negative. So this 2 negative is equal to these, what we're talking about. So if the Brs are equal to a 2 negative, then the Fe's got to be equal to a 2 positive. There's only one Fe, so that Fe takes on the entire 2 positive charge. So starting from scratch, I would name the metal, so iron. Iron's got multiple charges in its box, so I put a parentheses. I name Br as an ion, so that's bromide. And we've determined that the charge on the Fe is a 2 positive, so this is iron 2 bromide. Why don't you try this problem? Pause the video, try that problem, and I'll go over it next. So in this problem, I find Cu, it's copper. Copper's got multiple charges in the box to pick from, so I put a parentheses. I name oxygen as an ion, so oxide. And now I go and do the charges. Now, some students refuse to do the charges. I don't know why they do that, because to this day, I still do charges. So oxide's got a 2 negative charge. So the copper's got to be equal to a 2 positive charge for this and this to add up to 0. There's only one copper there, so all of this 2 positive charge goes into this copper. So this is copper 2 oxide. Pause the video, try this problem. All right, so I find vanadium. Vanadium's got multiple charges in the box to pick from, so I put a parentheses. I find nitrogen. Nitrogen as an ion is called nitride. Now I go and I do the charges. I look in the charge in the nitrogen box, it's a 3 negative. But there's 5 of them, so that's 15 negative overall for all the nitrogens. The vanadiums must be equal to 15 positive overall to balance out that 15 negative. But there's 3 vanadiums. So this 15 needs to be divided amongst those 3. Or take 15 divided by 3 and you get 5. So each vanadium is 5. So this is vanadium 5 nitride. Pause the video, try that problem. Again, we have vanadium. Vanadium has multiple charges, so I put a parentheses. Nitrogen turns into nitride. Nitrogen has a 3 negative charge in its box, but there's 4 of them, so that's a 12 negative overall. So the vanadium's got to be equal to 12 positive overall to cancel out, so these always have to add up to 0. But there's 3 vanadiums there. So this 12 divided by 3, or this 12 put amongst the 3 that are there, each one is a 4. I want to make sure everyone understands that's watching this video. This is not the Roman numeral that goes there. Some students get that mixed up. This 3 is not the Roman numeral that goes there. You have to figure out the charge of each vanadium. That is what the Roman numeral is. This is the next problem we're going to do. Pause the video, try it. So in this last one, I have copper. Copper's got multiple charges in its box, so I put a parentheses. Oxygen turns into oxide. Oxide has a 2 negative charge. So that means all the coppers have to have a 2 positive charge. But there's 2 coppers right here. So this 2 positive charge needs to be divided amongst those 2 coppers. So each copper is a 1, copper 1 positive. So what would this look like? Well, it'd be CuCuO. We got a 2 negative charge there. All these coppers have to have a 2 positive charge overall. So each one is a 1 positive. That 1 positive is what goes right there in that Roman numeral. This is just showing you the difference of electrons. So here we got copper 2 oxide, or copper 2 ions in it, and we get this black color. Here we have copper 1 ions, and we get a nice reddish color. So they look physically different, and they react chemically different. So the difference of electrons absolutely does make all the difference in the world when they react chemically. Here's another example of that. Copper 1 ions with chloride. Copper 1 ions with chloride are green, and copper 2 ions with chloride are blue. They chemically react different and they physically look different. So the rest of this is homework for you to do.